Hello, welcome everyone. Can maybe everybody who's here for the first time quickly raise their hand? Because there are quite a few people. Okay, so I'll just quickly say a few words about Probe before we start. At Probe, we organize events to educate students and also the general public about psychedelic research and the use of psychedelics in therapy. And we have different kinds of events. This today is part of our lecture series where we invite professionals, researchers, therapists, anything to talk about their expertise and about their research as today. And besides that, we have our paper club where students themselves present research or papers that they find interesting or books. And then we have our movie nights where we show movies related to psychedelics, of course. And we have our integration circle where we provide a space for people to talk about their difficult or beautiful psychedelic experiences in order to integrate them better. Yes. So today, well, before I introduce our speaker, if you want to stay a bit after the talk and exchange about the talk and connect, we will provide a little apéro from our amazing apéro team afterwards, right outside at the tables, with some snacks and drinks for you. Exactly. And so tonight we have the honor to invite Morten Lietz as a speaker. And he is, well, first of all, he's a PhD student at the Molecular Psychiatry Lab under Gregor Hausler in Fribourg. Also a colleague of mine because I'm also working there. And he's also part of ALPS, where his main role is coordinating the speakers for the ALPS conference. If you don't know it, that's the biggest academic conference around psychedelics in Switzerland, which happens on the 11th and 12th October this year. And in his PhD, he's mainly researching neuroplasticity. But today, he's going to talk about psychedelics and cognition, which is talking about research that he did in the Netherlands, in Groningen, before coming to Switzerland. So I'm really excited. So please give a warm welcome to Morten Lietz.
Hi, I'm Morten. Thank you, Dave, for the welcome. Thank you, Probe, for organizing. First time that I'm here. I'm really happy because I've been lurking a bit in the WhatsApp groups and see how much events you guys are pulling off. And I also heard that there are a lot of people coming in, and it's pretty cool to have something like this so locally. So yeah, you guys do a great job. So I am going to talk a bit about psychedelics and cognition, which is usually a topic that is kind of underrepresented in the research field as of now. Hey, I made it. I started this project basically it's my very first attempt into the psychedelic research field in the Netherlands before I came here. I kind of gave up halfway through at one point because meta-analyses are a pain in the ass. And then I had another student of us who kind of took that over, and now he's at a point where he had a bit of a burnout, so I kind of got it back, and now I'm really happy because actually in the end it became quite an interesting project. So yeah, we're gonna talk a bit about that today. I'll give you a general overview of what we know about psychedelics and cognition. I will also show you a bit of the results that we had from another project that kind of feeds into this a little bit. So it's all semi-connected. Let's see how we will manage. Right, so I'm right in front of the slides. Let me remove myself. So let's start a bit with a definition at first. So when we say cognition, this is very cheaply ripped from Webster's dictionary. So the mental action or process of acquiring knowledge and understanding through thought, experience, and the senses. What we mean by that from a scientific perspective is basically all this. So all of these things are basically higher cognitive functions and lower cognitive functions. So we have like social cognition, executive functions, which are more like planning and mental flexibility. Of course, there's memory, which, well, depending on who you ask, can be considered cognitive function, or its completely own thing because it has its own underlying circuitry and stuff. And then, of course, we have attention and psychomotor speed, which is a bit more of the basic cognitive functions. So, why are cognitive functions so important? Well, basically, whenever something goes wrong in whatever way or form within your brain or within your psyche, your cognitive functions will most likely be impaired. So we know that cognitive impairments arise in neurodegenerative diseases such as Alzheimer's, Parkinson's, MS, but also psychiatric disorders. For example, when you are severely depressed, your working memory doesn't work as well anymore. There's a bunch of other stuff that happens, of course, when you are suffering from substance abuse disorder, when you're schizophrenic, but also neurological disorders like having epilepsy or TBI, which is basically you got whonked on the head really hard one time. But also neurodevelopmental stuff such as OCD. All of these are impacting your cognition in one way or another. So cognition seemed to be quite transdiagnostic. This is also what this paper was looking at. They weren't looking at all these things I just showed you. They were only looking at a few in particular. But they also saw that in particular in substance abuse, but also depression subtypes and developmental disorders such as ADHD and autism, you always have cognition as one of the affected underlying functions. Right. Interestingly, when we talk about transdiagnostic stuff, psychedelics are also quite transdiagnostic. So when we look at this diagram, which I made myself, we saw that specifically when we look at clinical trials, so the more hard science stuff, which is more rooted in like larger trials, rigorous methods. So these are looking pretty good in terms of scientific rigor, with end-of-life anxiety, cluster headaches, depression, addiction, PTSD. But also there's a bunch of ongoing investigations into several different domains in where we currently start off to see whether this will work out or not. So these are all small-scale studies, so take this with a bit of a grain of salt. But interestingly enough, even though we also have OCD and ADHD here, most of the outcome measures that these studies are using are not cognition. Most of these are affective stuff, such as depression score or well-being or just general ADHD symptomatic, but most of these don't look at cognition at all. Well, and I can tell you at the very end of this talk probably why that is, because it's a bit more difficult to assess cognitive functions during the acute phases of psychedelics. Plus, it also paints a bad picture, and you'll see what I mean at the end as well. So, how do psychedelics affect cognition? That is the big question. We were wondering ourselves back in the days, and we couldn't really find an answer easily, so we were like, ah, shit, somebody needs to make a meta-analysis about this. Well, first of all, a couple of things you guys probably heard about. There's a lot of hype, specifically in the field of microdosing. So you probably have seen some of this stuff. So microdosing can boost cognitive creativity, or mushrooms are the solution to all your problems, or can they make you more creative, and blah, 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 and so on and so forth. You get the idea. So this is kind of the hype, and now let's have a look at what the science actually says, starting off with a bit of theory. So first of all, who of you has heard of the predictive process theory of the brain? Yes, okay. So this is a theory of how our brain works in a very general sense. So the idea is that we have a sensory input that is basically the R, which is the reality. And then we have a specific expectation about the input that is coming in. And what our brain is doing is it looks at the input and our expectation and makes a comparison. How much overlap is there? How much different are these? And whenever there is a large difference, it has like this prediction error, and it kind of accounts for that, and it corrects its expectation. And that basically it does on several different layers. So you start at the very bottom, and then the higher up you go, the more fine-tuned this model becomes, basically. I will show you what I mean by that based on an example. So, quick quiz. predictive process theory, quiz number 1. So how do you perceive the squares? Who of you thinks that A is darker than B? Hands up, and be honest. Right. Who of you thinks that B is darker than A? And who of you thinks that A and B are the same color? Well, because you probably already know how to do multiple choice, it's always the stupidest answer, right? And yeah, of course you're correct. So A and B are actually the same color. Let's pay close attention to the color. It's not changing the color, it's only adding the grids. However, even now, your brain kind of keeps this notion of, no, but they are different, right? A is darker. And that is because we are so much used to that stuff that is in the shadow is darker. This is like a rule that our brain has ingrained. We know that when something throws a shadow, here, this floor, for example, we know, well, this is the same color, even though we don't perceive it as the same color, because there's a shadow on top, right? So this is kind of this expectation of reality that influences our perception of the world. And here you see this in a very nice example. Let's do another one. So you probably have seen this one, right? So again, what color is this dress? Who says white and gold? Who says blue and black? Who says blue and gold? So the thing is, the theory only goes for the first two. For some reason, I also see it as blue and black. I don't know why. I have also no answer for that. But again, so actually they researched this and they tried to figure out why that is. And they found out that because we see that this picture is oversaturated and we have an understanding of how oversaturated images usually look, our brain corrects for that already. And depending on whether you're used to more natural light, because you spent more time outside as a kid, for example, or you're more used to artificial light, so also this isn't super duper scientific, but these are some theories of why that is, you'll perceive this in a different way. And again, when we think about predictive process theory, it's about what your brain is used to, how reality is supposed to be like. And this is influencing our perception, even though I can tell you, for all of us, the pixels in here are exactly the same, obviously. All right, final example. So which animal do you see? Well, who sees a duck? And who sees a bunny? Right, and now when I tell you, for those people who saw the bunny, this is the beak, this is the eye, do you also see the duck? Yeah. This is another interesting example where when you have ambivalent images where both things can be true at the same time, that depending on what input your brain has, you can change your perception of the thing itself. And these are all very nice examples of predictive process theory. Now, any more questions about predictive process theory and how your brain uses top-down information to implement these ideas of perception? Great, because now let's have a look at what psychedelics do in the mix. Well, so this is also a bit of a more historic theory from Robin Carhart Harris. He was the one who brought that forth in the beginning. So this is the Rebus model, which stands for Relaxed Beliefs Under Psychedelics. Now, the idea is that this top-down mechanism, so the thing that has an expectation about reality, is disrupted because the underlying network that is responsible for this function gets desynchronized, so it doesn't work as it used to be, and thus the inputs that come from the more sensory input, they don't get corrected anymore, and your prior expectations about reality basically they're still there, but they have less of an impact on what you see, but also what you feel, what you think, what your cognition is like. Because this mechanism isn't only about perception, it's also about how your usual cognition functions. And so this is like one of the models of how psychedelics change your cognition. And this has been very popular to explain all these different effects, in particular with depression and such. However, so they started off with this model, and the longer it's existing, the more exceptions they started to add in, and they really tried to fit every finding they had into this model. It's a bit redundant at this point. It's a bit old. I wouldn't be surprised if we start talking about this in a couple of years. But for now, this is still a working theory, and I just wanted to present it as such, also because I love to do these this questions in the beginning. Well, right. So with that being said, that was a bit of theory. Now let's move to what we have found in our meta-analysis. Just quick shout out to all the authors. So we have Parsa Yousefi, who's like we do shared first authorship, but he wants to be in the front because he still hasn't found a PhD position yet, and politic reasons, blah blah blah. But then we have like a bunch of other people. Also, Gregor Hasta is involved, Michiel van Elk, and Stephanie Enriquez Geppert, who was the person who initiated that project together with me. Right. So first of all, for those, who knows what a meta-analysis is? Quick show of hands. Then for those who don't, I'll quickly let you know what I mean when I say meta-analysis. So in science, you usually have this nice pyramid. So you start off with like expert opinions. That's just basically a guy who's been doing this stuff for a couple of years, and he just writes a paper. I think that psychedelics are cool because of there's not much scientific about it. There's a lot of bias involved. There's basically no data, and then the more you move up this hierarchy. Somewhere here you have the randomized controlled trials, so they have like double blinding, they have different groups, and then above it all you have systematic reviews and meta-analyses that basically look at all the data that has been collected in a certain field with specific parameters, and then they pool them all together and they run one big fat analysis about all of these. And that's kind of what we did. We went through 3,000 to 4,000 papers. And we tried to extract reaction times and accuracy scores of stuff where they use some form of cognitive test. So these had to be objective in some way, so these were test scores. This was the only way for us to, but we had to make some decisions, and this was what we came up with in the end. And we ended up with, here it still says 10. We actually, I didn't have time to update this figure. We now ended up with 13 papers in the end. That were included. So you can imagine that was a lot of reading through in order to end up with 13 papers, but at least we can be sure that we found more or less all of them at this point. And what we identified is most of these papers, they were looking at these domains, so executive functions or attention. There was one paper that looked at psychomotor speed, and of course there's also a bunch of memory stuff, but for us memory was a different domain. That would just overcomplicate these things, so therefore we decided not to look into memory and focused on executive functions and attention. And these were the papers we found. The papers in particular aren't that important, but we have some papers that looked at attention, conflict monitoring, inhibition, multiple EF, that stands for executive functions. That's basically like something where more complex planning and also other cognitive functions are involved. So this is basically like a not so clean score of executive functions, but just a bunch of executive functions together. And working memory, of course, which is an executive function and not falls under memory, just so you are all on the same team. Right, so we looked at accuracy, so how many responses were correct. This is really hard to see. I'm well aware of that. I can't make it much bigger, unfortunately. But what we found is the thing is something is different from 0 if it is outside of the bracket. So the bracket you see here has to be on the side and not going through the line in order for that to be in effect. And when you sum all of these up, you see there's not much going on. So we have actually identified that under the acute phase of psychedelics, in particular psilocybin, because that's what we looked at, there is no real difference in terms of accuracy scores, which is a good sign. So you don't make more mistakes while being super duper high on psilocybin, which was kind of a bit of a surprise. However, when we look at reaction time, the story changes a little bit. So the people, as you could hear, this for example, that's like a big effect, that's a big effect. So when we sum up all of these, we do find that actually the people got slower in terms of reaction time. So there seems to be something going on within their cognition that makes it harder for them to perform properly, which means that they had to slow down in order to not make much more mistakes than they would usually do. But of course we also looked at moderators. So for example, we looked at dose. ranging from microdose all the way up to a high dose, which is 30 milligrams of psilocybin or more on 70 kilos of body weight. We also looked at timing, so whether they were they were measuring cognitive functions during the peak or after the peak. We defined peak as between 60 and 210 minutes. Then we looked at the sensitivity of measure. So because you can measure cognitive functions in many different ways, some of them are very precise, some of them are a bit more general. We plugged that in as a moderating factor, and of course we differentiated between all the cognitive functions, whether, for example, attention is more affected than working memory or inhibition. And well, this is what we found. So as expected, dose had a moderating effect. So there is a dose response curve, as one would expect. The more psychedelics you ingest, the more your reaction time will be impacted. Timing does not seem to play a role, so it doesn't really matter when you measure throughout the duration of the trip. Again, keep in mind during the acute phase, so this is while they are still actively feeling the substance and not the day or the week after. The sensitivity was also significant, which was a bit of a surprise, because that means that the more sensitive the measure, the less the effect, which is kind of hinting towards the fact that there might also be a little bit of a bias involved. So because technically, if we would have like a true effect in executive functions, then this should have been the other way around. We also had small sample sizes sometimes, so we don't really know exactly what to do with this, but this is something to keep in mind. And ultimately, cognitive function also seemed to be equally affected. So there was no difference between attention or working memory or inhibition or the other functions that we measured, which was also interesting in itself. So that kind of suggested that there might have been an underlying structure that has been affected in some way that affects all of them in an equal amount. That was kind of our take home from that part. Right. Now that brings me to the synthesis. So we were of course looking at these findings and we're trying to come up with a model that is testable, but also brings forth a couple of new ideas. And this is what we came up with. Now, of course, when you have these pharmacological interventions, you can look at them at many different levels, which is exactly what we did. So we started at the pharmacological level and we hypothesized what our results could mean in terms of serotonergic and dopaminergic action, how that would affect the networks on a neuronal level, how that again could potentially be affected in a cognitive model. Specifically, we looked at cognitive control and dual tasking or multitasking. And of course, underneath it all, how motivation might play a role, which hasn't been assessed in any of these studies. But I'll come to that in a bit. We're going to go through all of these systematically. So let's start with the pharmacological level. Now, most of you probably know that psychedelics kind of act as serotonin. So they attach to the receptors that serotonin usually attaches to. And that's how they do a lot of their magic. At least that was the story that most of us kind of grew up with coming into this field. But it is, of course, a lot more complicated than that. For example, LSD also works via the dopamine system. And psilocybin also plays around with the dopamine and the serotonin, but depending on where you measure it, it goes either up or down or left or right. So, not left or right, that was a joke. But so there's a lot happening in both of these receptor types. So let's have a quick look. So for example, in the nucleus accumbens, which is more of the deeper layers, so subcortical layers, so they're very deep within your brain. This part is also responsible for your reward system. We see that the administration of psilocybin, this is in animal models by the way, leads to an increase in dopamine, whereas it does not so with serotonin. However, when you look at the prefrontal area, so the thinky parts of your brain, then you see that there is actually a reduction of dopamine and an increase in serotonin. So there seems to be something that usually is in balance, and what psychedelics do, they kind of shift the balance in favor of one or the other. Now, this becomes interesting when we look at something called a receptor density, something MRI measure. I forgot the particular term, but basically what they do, they scan your brain using an MRI machine, and they use a specific technique where they can quantify how much of the drug works through what type of receptors. Very advanced. To be honest, I didn't fully understand the paper. I'm still going to talk about it though, because the results are quite nice. And so what you see is that here. So if like the serotonin, the serotonergic action of psychedelics, they correlate with hallucinations and complex imagery, so more the perceptual effects, whereas the dopaminergic action of psychedelics seem to correlate more with cognitive effects. Now here it says principal component 2, which basically means so they did like a specific analysis for like a questionnaire where they asked people about how much of their cognition was impaired, and this was like one subcluster they identified. So just to recap, serotonin mostly associated, within this study at least, with the perceptual effects, whereas dopamine was mostly associated with the dopaminergic effects. Now that's quite interesting, because that kind of hints towards the possibility that all these cognitive effects of psychedelics might actually not be due to the serotonin alone, but also because of the dopamine. So yeah, that is something we found very interesting, and also is a bit more in line with what we find. So yeah, but let's move on. Let's look at how the change in these systems might affect the neuronal levels. So well, first of all, what we see is that there is when we look at the cognitive networks. So these are the higher cognitive function networks, in particular the executive function networks, and the networks in which LSD has an effect, or basically alters connectivity. There is quite an overlap. So here, these. I mean, you get the picture, right? Like, so the psychedelics seem to be actively affecting the same networks that we usually use in order to use higher cognitive functions. So therefore, it's not surprising that we also see these effects. Now, in particular, one area seems to play a key component when it comes to cognitive functions, and that is the claustrum. So who of you has ever heard about the claustrum before today? Okay, that's actually more than I was expecting, because I also, even though I come from a neuroscience background, I completely ignored the claustrum for most of my existence, because it's just like this thin layer that is something between the substantia nigra and like the insular cortex. Correct me if I'm wrong. I'm also a bit rusty on neuroanatomy. And yeah, like the main function of the claustrum was always a bit of an enigma, but slowly but steadily we kind of have an idea what it does. It's quite quite difficult to really explain on a more scientific level, but I'll try to keep it as simple as possible. Most people say that it's basically the conductor of your brain. So the claustrum is the thing that kind of gives the tact to all of your other networks within your brain. So it gives the rhythm, the amount of upregulation, downregulation, depending on what task you do. So it's a very, very important part of your brain that also has a lot of innervations to a bunch of other parts of your brain. So like connections to other parts of your brain. It has been involved in sustained attention, and people suggest that this might also be a key component when it comes to our consciousness. And most importantly, it has been associated with cognitive control. Now, and these are all the different connections that the claustrum has. So it's like connected to all these higher cortical areas, but also subcortical areas. So it's basically like an integrative hub of sorts. Now, the claustrum has been coined like the maker of cognitive control. So what do I mean when I say cognitive control? Well, basically, in simple terms, cognitive control is the thing that you need in order to voluntarily shift your attention from one thing to another. Because like when I do this, but I want to keep talking, I have to actively use cognitive control to not be distracted by my own stupid snipping. This is cognitive control in easy terms. So you kind of have to take everything, all the cognitive, all the input that you get, and your cognitive control voluntarily decides what you want to spend your awareness on, basically. And this is the claustrum that is probably doing that. That's at least the theory. Now, psychedelics, they do kind of disrupt this whole system. We don't have to look at this in detail. They do so mostly via the serotonin system, but also via the dopamine system. It's basically like throwing a bit of sand into this machine. So it starts to stutter a bit, it starts to do weird stuff that it usually doesn't. So that's the thing, like just imagine you are an orchestra and your conductor is on psilocybin. That's basically what it is. So it's going to be slightly different, it's going to be slightly out of whack. So this is kind of the easiest way to say what the claustrum is doing in this sense. But not only the claustrum is affected, also the salience network is affected. Now the salience network basically is helping your brain to shift between states. So states, for example, are you have two main states within your brain. These are either the let's do nothing state and the let's do something state. So the let's do nothing state is basically the default mode network that gets active when you don't do nothing. Interestingly, when you meditate, this also becomes active. So when you don't do a task, this seems to be the active thing. So this is your default state when you don't do stuff. And the central executive network becomes active whenever you actually want to do stuff. And your salience network helps to turn one on or the other. So this is basically, again, this overarching structure that decides, hey, do we want to actually do stuff now or do we don't? Based on information that comes in. And it allocates the resources to one or the other to activate the one state or the other one. So again, it's a quite complex and integrative structure that plays a major role here. But also has been involved in all these other things. Most importantly for the detecting and filtering of salient stimuli. So salient, for me, that was a bit of a term that I had to Google at first, means that stuff that is important to you. So for example, me looking at the slide right now, that would be a salient stimulus. Whereas the noise that the beamer is making wouldn't be a salient stimulus because it's not important for the task I'm currently doing, and therefore my brain easily just filters it out. It really doesn't matter that this thing is there. I don't hear it actually. I really have to focus so that I hear it. And this is the main function of the salience network. First, look for important stimuli, decides what is important and what isn't, and second, initiate the go or the let's do nothing. And that's of course also psychedelics, they affect this network also in a very peculiar way. It's not important how that happens exactly, but just quickly walk you through. So usually the salience network is inhibiting the default mode network, whereas on psychedelics it excites it. So, but what that exactly does is not really important for the story, so we can just move on. But how does all of this look on a cognitive level? Now, this is actually the exciting part because this is where we get our results from. We measured on the cognitive level, and we kind of constructed all of this stuff based on what we've seen here. And we kind of came up with two working theories of that could explain our findings. Now, they kind of work hand in hand, but I didn't have time to make one graph, so I'll just walk you through one by one. So the first one is this idea where cognitive control and salience is at the core. Let's first all look at this side. So normally the way your brain works is you have an intact claustrum cortical circuit, which is standing like here the CCC model, and your salience network is also completely fine and does its job very well. Now, let's say you are doing an experiment. You are in a hospital, they want to run some tests on you, and you have to do a very boring cognitive task. Quick show of hands, who of you has ever participated in a cognitive psychology experiment? How was it? Was it as exciting as, no. It's boring. It's very, very boring. Cognitive tasks are usually, you see a stimulus and then you press a 1 or 0 for 15 to 20 minutes. It's hard to be awake during that time. It's very, very monotonous. Still, we kind of do it to the very end. Did you finish it in the end? Yeah, you did. Why? Why did you finish it?
Well, because I had to.
Because you had to. And what makes you feel like you had to?
I get credits for it.
He get credits for it, exactly. Of course, there are other reasons people get money for it, but also there's stuff like you don't want to be a dick. I mean, you already came here, and the researchers spent some time explaining, so you don't want to be an asshole. So there's also a bit of social pressure involved, and all of these things, they form something that is called contextual demand. So all these external things that make you do the task can be seen as high contextual demand because you don't want to be a dick, right? And you get credits and you get money. So the monotonous task, even though there's very low salience, is very boring. Whereas all the other stuff you could be doing is potentially slightly more interesting. Like you could be eating, you could be singing, you could be playing video games on your phone. Still, your brain uses cognitive control to, even though there is this imbalance in salience, to kind of overrule that, because fuck it, here the contextual demand is more important, and thus we overrule our imbalance in salience. And this is what usually happens, and in the end you kind of do the task you are expected, and you don't just put your finger in your nose and do nothing. However, now let's look on the other side. So as soon as we throw psilocybin in the mix, two things happen. First of all, your colostrum is not doing the orchestrating thing it usually does, and thus your cognitive control mechanism is slightly impaired. But also, your salience network is kind of out of whack, and suddenly, everything that used to be just an easily ignorable distractor is potentially way more interesting. So it increases in salience. So, for example, look at that wall over there. Now this has like a nice texture. Now imagine you are in psychedelics and this is just expanding everywhere, or it's breathing, or it's doing wiggly stuff, or you see something in there. This is something that people report specifically also in our study quite a lot, that the stuff behind the screen or the stuff on the screen is becoming alive, and I don't know, like the dots they see are children chasing each other, something like that. So like it becomes a lot more lively, and suddenly all these distractors, they're like super interesting, they're super salient, and suddenly you have even more pull towards focusing on the distractor, because the task still remains kind of boring. I mean, not the task per se if it becomes alive, but the stuff you're supposed to be doing technically becomes kind of boring. And on top of that, your colostrum isn't doing the thing it usually does, namely it kind of gives you the opportunity to say, no, we don't want to be a dick, let's do the stuff we're supposed to be doing, because it's kind of disrupted, it's not doing the thing anymore, and thus you will probably end up spending more resources on your distractors, that the stuff you're not supposed to be doing actually in that time. Now that's one model that we kind of push forward. It's quite out there. It's definitely more like an idea, more an hypothesis that definitely requires a lot of testing down the line. So take all of this with a grain of salt. It's kind of just an idea we had to bring forth. Why not? But yeah, another idea we had, how we also could interpret this, is by basically looking at the psychedelic experience as a dual task. More familiar for you guys, probably multitasking is a thing, right? So what happens when you multitask usually? Anyone knows? Anyone wants to say?
Performance deteriorates.
Exactly. So that's why you're not supposed to call someone while driving, for example, because your brain, that's a nice thing, your brain actually is pretty shitty at dual tasking. In fact, there's no such thing as doing stuff at the same time. Your brain is always switching back and forth in a very fast manner between stuff it's supposed to be doing at the same time. So every time you switch, there is a moment of recalibration where your brain has to adjust to a new rule set, and that usually comes at a cost, and that's quite interesting because that is usually reflected in slowing of reaction time. Not in accuracy, but in reaction time, which is exactly what we saw, and that's kind of why we came up with this idea on top of the other one. It also kind of plays nicely into the salience network deficiencies or alterations that we see, because your distractors become more interesting. So basically the idea is that while you are doing a task and you have a psychedelic experience, the psychedelic experience acts as a second task because it is as impactful as if you would just have to do two things at the same time, and thus what you see is similar to a dual task. Again, this is just a model, just an idea we kind of put forth, and let's see how this will hold up with a wheel of time. However, this is actually way easier to test in upcoming experiments, and it's also something we plan on doing, and that's why I also had to wove this into the mix. Yeah, right. Moving on. Now, underneath it all, of course, there's this factor of motivation. I'm not gonna waste too much breath about it, just read the quote. Yeah. Let's do another one. Right. So, yeah, I mean, come on. So motivation isn't usually assessed, even though it of course plays a huge role, and specifically when you work with psychedelics. And studies have shown that people report that the psychedelic experience falls within the top 5 most meaningful experiences in their life. They might not be so keen on actually doing your experiment, and might be, there's a bit of a discrepancy between what the participants want and what the experimenters want, and of course this is impacting our tests in one way or another. So of course we only looked so far at short term, so this is all during the acute phase, but of course the more interesting part is what happens long term. This is a bit of a different story. So there's this one paper by Doss et al. Who've actually who tried PAT, so this is psychedelics in combination with therapy in people who are suffering from depression. Again, this is one of the earlier studies, so open label, small scale. They only had like a waiting list control group. And what they saw is that people actually got better in a task assessing cognitive flexibility, and this was seemingly not correlated to their decline in cognitive in depression symptoms, which suggests that this might be independent to some form or another. It doesn't have to be. It might also just be statistical fluke, but there is a chance that even though psychedelics acutely reduce your cognitive functioning, in the long term they actually might benefit you. But only this one paper has looked at that so far, which is wild. I assume there were way more. By the way, we are also doing like up to 3 months afterwards. So we hope to add a little bit to that story. But yeah, like, so the idea behind it is that maybe what psychedelics do is they work on this imbalance between flexibility and stability within your brain. And that's how you kind of have this cognitive improvement over a long term. So let's look, for example, at people who are severely depressed. Usually you are in a very rigid state of mind. So when you're depressed, you kind of hard to it's really hard for you to implement new changes, like positive changes, but also negative ones. Like you're kind of stuck. That's kind of the idea. And what psychedelics are doing, they increase your cognitive flexibility quite a bit during the acute stage, even though they negatively impair your cognitive functioning otherwise. But there is like a bigger metacognitive thing going on that makes you realize the value of being more flexible in your mindset and in your ways. And through that, in combination with the heightened neuroplasticity afterwards, which is a completely different topic, but we don't really have time to go into that, you might actually learn something out of that experience, and that's how you get better. It's a very unsatisfactory explanation, to my opinion, at this point. But yeah, I think it's a bit too early to tell. But I just wanted to show you this for completion's sake. Right. So let's talk a bit about the implications of our findings. Well, we definitely need better tasks because, not only the motivational aspect, but also this potential influence of having to do like a dual task next to the stuff you're assessing, but also all the things we talked about, they all negatively impact the thing you want to measure, which lets the results look like you actually have reduced cognitive function, whereas maybe the tasks are just not right to measure cognitive function in that very peculiar state. And so one thing, however, we can do is try to get inspiration from other fields where you actually find improvements that kind of go into that direction of cognitive improvement. And what I found in particular was a paper on, actually multiple papers on psychedelics and mindful meditation. The reason why I looked at mindful meditation is because you need to cultivate focused attention in order to get a more mindful state, and also to get deeper levels of meditation. You need to really cultivate your attention. Please correct me if I'm wrong, because I'm a novice when it comes to these things, but cognitive functions are also important when it comes to meditation. And what we see is actually that people who went to these meditation retreats, they they definitely have an improvement in meditation depth on the day of the psilocybin treatment. And this, although this was not significant, there seems to be a trend that their mindfulness levels were also increased in one form or another. So the point I want to make here basically is that what we have to probably focus on if we want to have better results during the acute phases of psychedelics is that we have a task that aligns with the psychedelic state and that keeps in mind the abilities and limitations of the population that you're currently assessing, and not some task that is just developed on a population that is completely not the same population that you're currently investigating. Because, like, for example, when you look at neurodevelopmental research, where you investigate the cognitive abilities of a 2-year-olds, they don't read, they don't understand your cognitive task batteries, but you developed a task that has in mind what this population can do. And I think we can learn a lot from that field and also from meditation research, and try to come up with ways to better assess cognitive abilities under the acute phase of psychedelics. Or we go a completely different direction and just say, you know what, the direct route between psychedelics and cognition, kind of iffy, doesn't really work out that well. Let's focus on something else, namely neuronal plasticity. Can we maybe just use neuronal plasticity of psychedelics in order to boost our cognitive performances? Well, this is a question we also kind of asked in the Netherlands. The idea behind it is that let's look at this. Let's say your brain is a pot of rice, which you kind of let stand for. You got a bit of a burn on there, and you kind of forgot about it, and now it's all dry, and now there's a big nasty crust, and you can't get it off. Well, you can. You have to just keep scrubbing. You use an intervention. You kind of scrub. It takes a lot of effort. What you can do though is, of course, overnight you let it soak in water and a bit of soap, and then the day after the change will become easier because you. Okay, now I'm mixing metaphors, but the idea is that you basically put your brain in a state in which it is more accepting for change. And this is kind of the idea behind using neuroplasticity or something that enhances neuronal plasticity, such as psychedelics, and then combining that with a certain intervention to guide that neuroplastic change in order for change to happen within your brain. And this is the basis of the other project I was involved in, which was my very first research project. That was really cool. What we did was we tried to use psilocybin microdosing in the form of truffles, and combining that with a neuromodulator, which was neurofeedback, in order to boost cognitive performance, in particular executive functions. And just a quick story on what neurofeedback is. I think I'm still good on time. Yes. So neurofeedback, very simple. You get an EEG glued to your head. It's basically a bunch of electrodes that read out your brain waves. And your brain waves are usually connected to cognitive functions, specifically the ones that you measure right here. And what we know is that when you train specific brain waves, then your cognitive performance is enhanced, because it basically means that the network that is responsible for that cognitive action is basically trained as well. So you can see it as if this part of your brain is a muscle that you basically just go to the gym, you use that muscle, and thus the muscle is growing. Now, while your muscle needs stuff like protein and nutrients in order to grow, your neurons, they need to be in an environment in which neuroplasticity is high in order to change easily. And that's kind of the idea behind throwing the mushrooms in the mix. But I get off track. So first, neurofeedback, you get readings on how your network activity currently is performing. In form of an image, for example. This can be like a square that changes color. When the square gets red, that means that you're upregulating that network activity. When it gets blue, it means you downregulate that network activity. And all of this happens live. So you basically see in real time what goes on in your brain, and therefore you can train those networks by, for example, doing meditation exercises or arithmetics or calculations in your brain, spatial rotations. You can find out what method works best for you to train that specific network, which is kind of the interesting part, because nothing works for, like, there's not one solution that works for everyone. Everyone kind of has to find out what trains their network best. Right, that's neurofeedback. This was our study design. We tested before and after. We don't have to go into this. The passive control group, they also microdosed, but only after everything was done, so they were waiting list control. And what we saw is that in the first session, they weren't very much able to upregulate. In the second one, kind of better. In the third one, yeah, somewhat. And if you average all of this, you see there is a bit of a trend, but it's not necessarily better than if you would only do neurofeedback without the microdosing. However, we can't say for sure because we didn't have the time or the money to actually include that as a group as well. However, it has potential, and we were kind of glad to see that people liked it and that they were able to do it. That was the first step. And then in follow-up studies, we hope to get more funding and then do this in a more of a clinical trial scale with like 4 groups and all that stuff. Did their cognitive performance improve? Nah, not really. So at least not in the way we measured it. However, we asked them in terms of a questionnaire, and there they said, yeah, they did see improvements, but this could all be due to placebo. So take all of this with a grain of salt. Also their goals, the goals they wanted to achieve, they said they did achieve. But again, this is all subjective measures, so let's not read too much into that. Right, okay, we're in the end. These are my sources. Any questions? Before we come to questions, there's a bunch of advertisement. I'm currently recruiting people for my study. We're going to look at neuroplastic changes in the brain in people who are 55 years or older. I got a bunch of flyers for that over here. We can talk about it. But you can also find all the information on our website through the QR code. If you know anyone or you yourself know how to use Starta, you can also apply. We definitely need someone who knows that program in order to work on some data which are collected from psychedelic patients. We don't know how to use that program, and thus we need someone to help us out there. So if you want an internship and you can work with that program, you're more than welcome to apply. And now we can come to questions. Yes. Thank you. Yeah, sorry, that was a lot for that time of the day, right? Yes.
Can you go back to slide, I think it was slide 10 or so maybe, when you showed the moderators. The moderators,
yes.
Who were significant, who were not significant. Yeah, 20. Can you explain again the sensitivity thing?
Yes. So
what does it mean, or what does it mean? And yeah.
So when you measure executive functions, you usually have a non-executive function condition and an executive function condition within each task. That means, for example, let's say you do a working memory updating task where you either have to say the stimulus you see right now is the same or different than the previous one, or that would be the general condition, or you get another cue that tells you have to do that for the one that is 2 stimuluses before the one you currently assess. That is the executive function one. Now what you can do is you can basically just run your statistics on an average of all of these together, of the general performance, or you can actually subtract the difference between conditions in different tasks, and that will give you a more pure measure of executive function. Because all the other stuff is, for example, psychomotor speed, together with attention, together with a bunch of more general cognitive functions. And this is kind of, something like people, you could tell that the people who did most of these studies, they weren't coming from a cognitive psychology background, because they didn't do these subtractions in their methods, statistically speaking, and thus they were sometimes reporting more general measures of sensitivity. Yeah.
Which kind of also had included reaction times.
So they had sometimes more general. They reported more generally the effects, rather than actually doing the right thing and only looking at the difference between the easy and the difficult condition.
In the end, before you drew your 2 conclusions, you were talking about the way in which cognitive flexibility is enhanced through. Now I have a blackout with the word.
I get you. It's been a long day.
Yeah. Neuroplasticity, right? Could you explain? You went through that very briefly.
Yeah.
So that you kind of learn afterwards from your psychedelic experience, like as an example of how you could use your brain in a more flexible way. Is that how that would work?
So this is the model that has been proposed by Sayali and Barrett. Barrett is basically the guy when it comes to psychedelics and cognition. So their idea was basically that, first you have the psychedelic experience where you see how beneficial enhanced cognitive flexibility can be. And then at the same time, you have this window of neuroplasticity afterwards, where your brain is also in a state in which change comes more easily. Now you have 2 things. You have this cognitive level and this insight that 3 things. So the insight that cognitive flexibility is good, you have the cognitive flexibility itself, and you have a brain that is able to acquire a different state more easily. And these things together might help you overcome your depressive symptoms. Well, I would say if you are in therapy, because otherwise you are in the state of mind, but you need to guide this process somehow. And usually a therapist is very good at doing that. Yeah.
And the idea is that cognitive flexibility stays with the neuroplasticity after the experience. They did find this enhancement for up to 4 weeks. So this was the last time they measured. So generally, I would be careful to say that it goes on much longer than that. But exactly when this effect subsides remains to be seen. So we will also do our cognitive tasks up until 4 weeks later, and then we will do another round of questionnaires up to 3 months afterwards, but we also don't have the resources to do another round of tasks. So, right.
I just wanted to put in there that I was in a seminar and it was exactly about this, how long the effects of neuroplasticity were lasting. No, it was antidepressive effects they were describing, and they could still measure antidepressive effect with VAT after 4 years.
Wow, that's crazy.
Yeah, just wanted to show this.
Yeah.
Yeah, I mean, that's the nice thing. Like, ultimately, we hope to achieve lasting change, right? So, and I think the specifically in terms of depression, it does seem quite promising that these changes actually, there seem to be some knowledge that you gain through these that help you in the long time that you don't lose. So this isn't just a drug effect or transient effect. There's an actual change happening within you, and that's how you get better. Yeah. Yes.
What are the better tasks?
What are the better tasks?
Yeah.
Oh, right. I completely skipped that part. Well, so we gave that some thought. I was a bit inspired by my colleague Abigail, because what she's doing, she's using a very basic episodic memory task where you show someone pictures and you don't tell them to memorize them, and then a couple of days later you ask them which of these pictures have you seen before. Very basic. But the way she did that was she made the background look like an art gallery. So, and the instructions were also like, imagine you're in an art gallery and you walk through the halls and you look at all these pictures, and the people love it while they're on psychedelics, because they actually feel like, wow, I'm in an art gallery. This is so cool. And then it's just a very simple thing, but then suddenly you have these people who are super engaged with the task and they love looking at these pictures. And they're really, they're not turned off by the fact that it's just like, because that's the thing. Like usually these, you always have like a gray background, such as here. This is literally like the picture you see here. Here. This is literally a copy from a task that we were doing back in the Netherlands. Like I just screenshotted it and just made it smaller. And it doesn't have to look like that for some reason, and people just agreed to never change it afterwards. And that's why this is the validated format, and that's why we use it that way. But you can be creative, make it a bit more appealing to someone who's on psychedelics, because this is depressing, my opinion. Or something that I'm doing. So I've been looking at what is actually improved acutely, and what seems to be improved is autobiographical memory. So memory that is related to your own personal history. People seem to have more access to that, and they seem to have more detail and all that stuff. So what I'm going to do is I will give people a specific aroma, which they have already did some screening up front, so I know which aromas would work well for that person, because they told me how familiar that aroma is to them. And then I try to induce like a memory with that aroma while they are on psychedelics. And then we do an interview, and based on their responses, I can basically estimate how much detail or how rich in detail their memory is. And because it is personally meaningful, I don't have this divergence between the something boring and something that is personally meaningful, because it is like people like to talk about their childhood memories when they are tripping. This is something that my professor saw when he worked with his patients. This is a general effect we've been observing elsewhere as well. So people really kind of get lost in their own memories for a while, and so this is kind of my takeaway, to find something that works in synergy rather than in competition with the psychedelic experience. Yes, thank you for that question.
Thanks for the investigation. But then you would interview the person twice with the smells and like have the answer twice and look at the differences?
So I wanted to do that, but that comes with a bunch of problems. Like people get better at stuff like that. You can't use the same smells twice. I ended up with only 15 smells that were reliably working very well, so I can only do this once, but I have 2 groups. And I have 80 people, so I have 40 in each group, and that is hopefully enough to detect a change between...
Rain on wet, like wet asphalt or something, and then maybe there's a memory.
Exactly. Like half of them will get psychedelics, the other half we'll get like a lower dose of psychedelics, and then we can see that there is a potential effect between those. Yeah. Yes.
Okay, you had the slide on depression, on my results, paper results in depression. Are you aware of any studies looking at bipolar disorder?
So I have recently heard that bipolar is something, at least that in therapy some people are doing. Studies I'm not aware of right now, because bipolar, seems to be slightly higher risk for having like a negative experience. Mostly along those lines that psychedelics are somewhat destabilizing. So they work very well for stuff where you have a very stable mindset, like in depression. Whereas when you have something which is a bit more volatile, as in bipolar, it might be a bit more, dicey. But then again, I'm no expert on that. So, and the field is also rapidly developing. So I wouldn't be surprised if in like a year or two, there's also a big study coming out of that. Yeah. Yes.
The fact that dopamine is released in the nucleus accumbens was new to me, and I know that for other addictive drugs like cocaine and cannabis do that. So does that finding change something about the paradigm of psychedelics being not addictive?
Interestingly, no, because this study is also, as far as I remember, not very new. It's from 2015. So this has been known for a while. So the thing is that I'm not sure whether they also looked at behavior, specifically drug-seeking behavior in the animals they used for this study. But what definitely other studies were doing, they were looking at this very typical self-administration paradigms of addiction, where they give the mouse, the animal, a button that releases food or releases the drug. And when you do that with heroin and cocaine, at one point the mouse will stop eating and will only press the drug button, whereas in psychedelics it will press that psychedelic button once, and then it will not press it for a while and like kind of steer clear of that. Because being surprise high on mushrooms for a while might not be nice in per se, but also that does not seem to be this drug-inducing, drug-seeking behavior. Yes.
Also, to answer your question, the cocaine and the alcohol floods the nucleus accumbens, and the psychedelic, as you can see, the psilocybin really goes in smoothly, and there's a larger plateau. So maybe the long-lasting effects on the nucleus accumbens might not be so severe, just the hypothesis.
So he's a substance abuse disorder specialist, actually, so therefore I trust his opinion more than mine in this regard. Yes?
Because you asked about the meditation and the methodology, I think that's really something to explore more. I was once in a study after a 6-week meditation retreat. Psychologists from Harvard doing psychological tests, and it was a big sample of 100 people, and everybody scored worse after the 6 weeks. So, and I think it's really the way the methodology is designed, and subjectively I felt like a bit of the same that you described. It's a bit, it's less interesting, really, even less interesting than before. And I thought that perception-wise, I felt it was more. I was more open to registering whatever was going on in the building, besides just what I was assigned to do the task. So, like what people are doing in the room next door, for instance, or outside the door. So, and I guess it's really difficult to adjust for that, or to come up with methods that are suited, especially in the acute phase. It's so distracting.
Yeah. I mean, that's also a very good point. And I mean, besides the autobiographical memory stuff, we're not measuring any acute effects on cognition. We do that before, we do that after. Because ultimately, what you said. Right now, we don't have the methodology that is validated that has a very clear effect. So it's kind of hard to discern what we actually measure. So but thanks for your insights. I'd love to hear more about this stuff. Yeah.
I'm still hung up on the dopamine and the serotonin thing. Because what I was thinking, I don't remember if I'm
if this is correct, but I think in rodents, or in mice at least, I don't know if this is in rats or mice.
So this is in mice.
It acts in around 60 minutes, right?
Mm-hmm.
So if you look at the serotonin, the peak is actually what you would expect, that it goes up during the peak of the substance and then it ends after 60 minutes. And then for dopamine, it's really, as you mentioned previously, like the peak seems to be towards the end of the trip, and then most of the increased dopamine is even after the trip is already over. So that's really interesting.
So in the frontal cortex, yeah. But in the nucleus accumbens, it goes up basically immediately. So also there's one hypothesis that I think I do have some additional slides that I kicked out in the end. So there's this basically negative feedback between your striatal and your frontal dopamine. So striatal meaning within your basal ganglia, the reward center of the brain. And frontal, basically being the higher cognitive function areas. And when your dopamine goes up in the basal ganglia, it goes down in the prefrontal cortex and the other way around. So there's the potential that what we see here is not a direct but a rather indirect drug effect, so that one part of the brain gets upregulated in terms of dopamine, which then has this negative feedback on other parts of the brain and therefore downregulates it there. Maybe, it's complex. It's
Just regarding these two maybe stereotypes between LSD and psilocybin, because what I knew is that I heard once psilocybin has no effect on the dopamine system, and LSD has or a bigger effect.
So LSD does have a little bit more of an effect on dopamine, but the graph I was showing here, this is using psilocybin. So this is a psilocybin result. So we haven't really replicated the findings that claim that LSD works on dopamine in humans. But again, it's not that it's only that nobody has tried that with psilocybin yet. So I wouldn't be surprised if there is something similar going on to LSD, maybe to a lesser extent, because when you look at the receptor affinities and stuff like that, so how much the substance likes to go to a certain receptor, then LSD has a higher affinity. But LSD has a higher affinity towards serotonin as well, and nobody really argues that psilocybin works less on your serotonin system than LSD. So point being is when we look at these receptors, there's a bunch more too. There's a bunch of different subtypes of dopamine receptors. There's a bunch of subtypes of serotonin receptors. There's noradrenergic stuff involved. We know that it has an impact directly on the BDNF receptor, which are involved in the neuroplasticity paradigms more. So these substances, they do a lot more than serotonin, 5-HT2A. And I mean, the interesting takeaway from this dopamine theory is a bit that these seem to be more explaining the cognitive effects, whereas the others are more the affective and this perceptual effect. So yeah, right. Cool. Then, thank you so much for having me. This was fun. I hope it wasn't too much into the substance. And you know what I mean. Also, right. So we have, of course, the conference. I'm not gonna speak there now. In a couple of years, I probably will. But it's ticket sales open. We'll start it will be in October. It's going to be pretty cool. It's going to be in Aarhus, also not too far from here. Go check it out. Okay. Thank you.